So the question then is why so should someone who's interested in healthier building materials be interested in the chemistry of these materials? And so one of the things to recognize is that the properties of materials are determined by the molecular structure, what the compounds that make up these materials and the chemical interactions and reactions, not just of the components that make up the material, but how those materials react with the environment, whether it's the air, the sunlight, and other chemicals and other exposure. And so to understand then how building materials can be healthier, it's not just about looking at the materials having optimum properties for the job, but also how these materials, what impact they might have on human health and ecosystem health. And so trying to understand what is best for the job is not necessarily just about optimum material properties, but also trying to minimize those impacts on health, on human health and the environment. And so an example might be is if you look at plastics. So historically, when plastics were first being synthesized in commercially, the starting ingredients for plastics have been fossil fuels, i.e. petrochemicals. And so if you look at just what the steps were involved in these petrochemicals being converted into plastics, it was the carbon dioxide emitted in the atmosphere millions of years ago being absorbed by plant matter that lived back then, through photosynthesis, that plant matter being converted into food, i.e. the nutrition for the plants, and basically converting the carbon and the carbon dioxide to carbon-containing molecules in the plants. And then over millions of years in Earth's history, that organic matter, the carbon-containing molecules, being converted into fossil fuels. And today, now millions of years later, we extract those fossil fuels, we use it for, obviously for our energy needs, but also fossil fuels are a primary source for starting ingredients for a whole chemical industry. And so plastics that we consider today, the starting ingredients, if you'd like, are coming from these petrochemicals and these fossil fuels. And so there's clearly not, the plastics themselves have properties that we rely on, whether it's for plastic bags or cups or whatever. And so what defines whether a plastic material is used for a plastic bag or a cup would be dependent on the components that make up that plastic, therefore coming from the fossil fuels. But as we've begun to recognize now, there's a lot of downside to that. We're using fossil fuels. The usage of that for the energy used to produce the plastics are resulting in emissions of greenhouse gases, contributing climate change, and the chemical processing of converting those feedstocks as starting ingredients to the plastics also have negative environmental and human health impacts. So the question then is there an alternate way can we do it? So we end up with the same product, that is the same chemical properties of the materials, but that be smarter about how we manufacture those. And so an alternate pathway might be, which often is known as green plastics, where we harvest plants which have been grown today. So the plants are undergoing the same chemical process, taking the carbon dioxide from the atmosphere, converting it through photosynthesis into carbon-containing molecules, and those compounds today are being converted into the feedstocks for the plastics. And so you can see now a very different, ideally a more renewable path towards the same plastic material, whereas the more traditional approach has been a very non-renewable pathway. Now, in this new path, also we have to consider how green, how sustainable is that. So there might be different energy demands, there might be different byproducts to be worried about. And so again, being smarter about how we don't create a new set of problems by a seemingly more renewable pathway is also where chemistry can play a role. And so you can see how, because fundamentally these materials are relying on chemical properties, whether we're looking at the plastic coming from fossil fuels or the plastics coming from these renewable processes, it's the same chemistry, just being smarter about the kind of chemistry we're doing and to minimize the impacts on humans and the environment.